Hello everyone. Today, we are going to talk about a crucial concept in machine learning, splitting your dataset into training and test sets. This process is a foundational step in preparing data for building reliable models. Think of it like preparing for an exam. When you study, you spend most of your time practicing with example questions, and then you take the actual test to see how well you've learned. In machine learning, the training set is like your practice questions, and the test set is the exam. Splitting data allows us to train a model on one part of the data and evaluate how well it performs on unseen data. So, why is it important to split your data? The main goal of machine learning is to create a model that performs well not just on the data it has seen during training, but also on new, unseen data. Without a proper split, you might end up with a model that performs perfectly on the training data but fails to work in the real world. This problem is known as overfitting, where the model memorizes the training data instead of learning patterns. Splitting the data into training and test sets helps us avoid this issue by keeping the test set separate, ensuring the model is evaluated on new data it has never seen before. The process of splitting data is straightforward. Typically, you divide the data into two parts, one for training and one for testing. A common split is 80% of the data for training and 20% for testing, but sometimes 70-30 or other ratios are used, depending on the size of the data set. Once you decide on the ratio, you shuffle the data to make sure it's randomized. Randomization prevents bias, where similar data points might end up grouped together, making the training or test set unrepresentative of the entire dataset. To make this process easier, Python provides a tool called scikit-learn, which has a function called train_test_split. This function automatically splits your data into training and test sets with just a few lines of code. It's efficient and ensures the split is done properly. Now, let's discuss some best practices when splitting data. First, for classification problems where you have categories, like yes or no, or different labels, it's important to use something called stratified splitting. This ensures that both the training and test sets have the same proportion of each category, preventing any imbalances. For example, if you're working with a dataset where 70% of the entries are yes and 30% are no, stratified splitting will maintain this ratio in both sets. Another important point is to avoid something called data leakage. Data leakage happens when information from the test set influences the training process. This can lead to overly optimistic results because the model has essentially cheated by using information it shouldn't have seen. To prevent this, always keep the test set completely separate until the final evaluation stage. Finally, to ensure consistency, especially when experimenting with different models or parameters, you can use a random seed. A random seed ensures that the split remains the same every time you run the code. This is particularly helpful when comparing results across multiple runs. To wrap things up, splitting data into training and test sets is an essential step in machine learning. It ensures that your model can generalize to new data and not just memorize what it has seen. By dividing your dataset into two parts, you create a foundation for reliable evaluation. Remember, use stratified splits when working with categories, avoid data leakage, and keep your results consistent by using a random seed. With these techniques, you're setting yourself up for success in building accurate and robust models. Thank you for your attention. I'm happy to answer any questions you have.